Okay, continuing for part 2 for the 8-1 notes, I was talking about how to find the angles for the triangle, and I decided to get a pencil here so I could show you the parallel lines, and then I could erase them afterwards. So here, this would be the transversal, and the angle that's 40 degrees from up above right here, this is the angle in here that's 40 degrees. So that is this angle right here, and so that makes this angle 40 degrees, which would make inside the triangle 140 degrees. So I'm going to erase the pencil markings. So in my triangle I have side angle side, and we can use law of cosines here and solve for our missing sides. So let's call this angle A, and this angle B and C, and so the side across from C would be little c and little b, and the length that we're looking for is little a. So the law of cosine starts out like the Pythagorean theorem: a squared is equal to b squared plus c squared, but then you subtract 2bc cosine of a. So filling in those values, we're looking for a squared. We know that b is 120 squared plus 80 squared minus 2 times 120 times 80 times the cosine of 140 degrees. This is where I wanted my calculator. 120 squared plus 80 squared. I want to do those first because I want to make sure I follow order of operations, and because the 2 multiplied by the 120 multiplied by the 80 multiplied by the cosine of 140, I would want to do those before I did the subtraction. And so that is equal to 20,800. So a squared is equal to 20,800. Make sure your calculator is in degrees. If you have an Inspire, you'd put a degree symbol after the 140, and that will guarantee that you get that your calculator will calculate in degrees. Or you can always take the sine of 30 degrees, which we know is 1/2, just to check that your calculator is in degrees. So I want 2 times 120 times 80 times the cosine of 140. And that's a negative number that I'm subtracting from my 20,000. 14,000. I'm going to round because I'm going to use the answer button on my calculator. So I want 20,800. Subtracting my last answer would tell me 35,500. So a is equal to the square root of that value. So a is approximately 188.4 feet. Now in my estimation above, I thought it was 195 feet, so I was a little off. 188.4 feet is exact. To find the bearing, we would need to find, I think we're just looking, we're just going to look for the distance in this. Other pieces, other definitions that we need to know are parallel vectors. So any vectors that have the same direction or opposite direction, so like vector A and vector C are parallel, they have the same direction, but also vector E because it has the opposite. Equivalent vectors have to have the same magnitude and direction. So E would not be equivalent because it has the opposite direction, but A and C are equivalent vectors. Opposite vectors would be A and E because it is going in the opposite direction but has the same magnitude. 2 more examples in the notes. First one is multiplying by a scalar, and then the second one is how to break a vector into its horizontal and vertical components. So here A vector can be multiplied by a scalar. To represent 3 times a, draw a vector 3 times as long as a in the same direction as a. To represent negative 3a, draw a vector that's 3 times as long as a in the opposite direction. So you would measure a, and a is approximately 2.8 centimeters, and so we would multiply 2.8 times 3, which is 8.4, and we would draw a vector in the same direction. So I want to make sure it's parallel here. Oops, hold your ruler. And this would represent, this is vector A, and this would represent 3a. If I want to go in the opposite direction, instead of having the tail here and the tip here, it would be switched. So in this example, they want you to find the resultant of 3x minus 3/4 y. So I want to draw vector 3x. So vector x is 2 centimeters, and I want to do this parallel here. So 2 centimeters, 3x would equal 6 centimeters. And there's my tip of 3x. And then here is y, vector y, 4.4 centimeters. And I want to draw a vector that is negative 3/4, so 75% of 4.4. So 4.4 times 0.75 is 3.3 centimeters. And so I'm going to translate this vector, keeping the direction. Now, vector y is going this direction, and I want it to be the opposite. So I'm going to draw this vector in the opposite direction, 3.3 centimeters in this direction. And this will represent negative 3/4 y. So I took the length and I multiplied it by 0.75, and then when I drew the vector, instead of having the arrow pointing in this way, I switched it, and this represents negative. So the resultant vector would be here, connecting the tail to the tip. And this vector right here would represent 3x minus 3/4 y. Last example, using some trig to break a vector into the horizontal and the vertical components. And so we're going to be using some drawing a right triangle and breaking to represent the vector. So in this example, Heather is pushing a lawnmower with a force of 450 newtons at an angle of 56 degrees with the ground. So here's my best drawing of a lawnmower here. There's the part with like the wheels, and then here would be the handle. And the 56 degrees I'm going to represent the ground here. This angle here is 56 degrees. And the force is 450 newtons. So the question asks us to find the magnitudes of the horizontal and vertical components. So so here's my drawing here. My horizontal and vertical components. Let me redraw that triangle so we can see it. This is 56 degrees and 450 newtons, and we're looking for x and y. Since I have a right triangle, and here is my angle, this is my adjacent side, This is my opposite side, and this is my hypotenuse. And if I was looking for y, opposite and hypotenuse, the opposite is what I'd be looking for, the hypotenuse is known. I could use trig, I could use sine. So the sine of 56 degrees would equal y over 450. I put a degree sign there, that was supposed to be newtons. And so y is equal to 450 times the sine of 56 degrees. Doing the same thing for cosine, we could find the horizontal component by the cosine of 56 degrees is equal to x over 450. So x would equal 450 times the cosine of 56 degrees. So the horizontal component, if I plug that into my calculator, 450 times the cosine of 56 degrees is 251.6 newtons, and the vertical component, this is x and this is y, would equal 450 times the sine of 56 degrees, which is 373.1 newtons.